In the preceding movie, we created a character controller that could wander around the level and interact with the physical objects in the scene, so that it could not pass, for example, through solid walls. One feature that it lacked was the ability to jump. Using that character controller, we cannot jump in the air and fall back down again under the effects of gravity. There are ways we could have implemented that behavior, but we did not do so. Right now, the object can just walk around on a flat plane. I want to introduce the ability to jump, but before I do that, I want to introduce an important concept that we're going to rely on moving forwards. That is the distinction between local space and world space. Right now in front of me here, we have this scene that you can find in the course companion files in the folder local to world. And if I select the capture object that we have in the scene here, and you can see that we have an object or a component attached, displace object. And what this component does is it simply moves the object forward in the direction in which it's looking. But notice that it has two properties that I have added here. This is not because they are functional per se, but I've added them so that we can see them or see their values inside the object inspector. We have the field local forward and transform forward. The local forward is simply the value vector3.forward, which is the forward axis. That will be 0, 0, 1. We have the transform.forward, which is the value that you get when you access the forward member variable of the transform component. You may think that this is the same as 0, 0, 1, but we're going to see that that is not the case. So if I press play on the toolbar, the object starts to move in the scene, and you can see these variables take on value. So the forward vector is 0, 0, 1, the local forward axis, but the transform forward is different. And in fact, if I move into the scene and I start to rotate this object, you can see that now this forward vector takes on a different value. So although the object is traveling along its forward vector in the direction in which it's looking, the value of the forward vector for the transform component is not 0, 0, 1. And I'm just going to visit that code inside MonoDevelop. I'm going to double click on the displace object script to open that in MonoDevelop so you can see the code I have used. Notice I've used the attribute for these two variables here, the attribute serialize field. When you append that to any private variable, the variable will display automatically in the object inspector. So this is a way that you can force private variables to show inside the object inspector. And that is what I have done here deliberately so you can see the values of these variables. Notice here in the update function, I'm assigning the local forward to vector3.forward, which is 0, 0, 1. But the transform forward, I'm assigning that to this transform.forward. And this represents the forward vector for the object. But this forward vector, unlike the vector3.forward, is expressed in world space and not in local space. So I'm just going to close MonoDevelop here and return back to Unity. So what's going on here is that this object has a forward vector. Now in local space, the forward vector is always 0, 0, 1 because it represents the direction in which we are looking, that is along the z-axis. But as soon as you turn this object to face a different direction so that the axes of this object no longer match up with the axes of the world, remember we have a distinction between local space and world space. When the axes of this local or this object here no longer match up to the world, then we get a disparity. We have the local forward vector of 0, 0, 1, but we also have that same vector expressed in world space, which could be a different direction. So we have this disparity between the two axes and coordinate systems. That introduces you to the distinction between global space and world space. Now sometimes we will want to work with local space, creating variables and vectors inside local space, and then we want to convert them to world space. This can be very useful, and we'll see how it can be so in the next video.